Acid. The definition of an acid is that it is giving off hydrogen ions to something. And hydrogen ion, these are just hydrogen atoms, just that they are ions, so not neutral, but they are having more positive protons as negative electrons. And it is also in every acid the positive hydrogen ion, which is there given off. It is always an hydrogen atom. And if mixed with water, then the molecule would split up to be able to give off its constituent ions. That is according to the Illustrated Medical Dictionary written by Sue Davidson, Penny Preston, and Francis Williams on the page 8. But this is no substitute for medical knowledge and also no medical advice, and the positions and views expressed are the ones of the source and not necessarily aligned with our own or with the ones of entities spoken of. Hi and welcome. I am trying to learn biochemistry today, acid, and after we've done that, we're gonna do wrist training, and if you participate in the wrist training, then it's at your own risk. Acid, a substance, and this is no medical advice or anything or substitute for medical knowledge, I'm just trying to read and to understand it. Acid is a substance defined as a donor of hydrogen ions, and where the hydrogen atoms with positive electrical charges. Now, what we mean here, we did previously once, I did a presentation called Acids, Bases, Salts. And that was something around that subject, so we already did somewhere in biochemistry something about acids. So an acid is any substance, or the definition of an acid is something which is giving hydrogen ions to something. And hydrogen ions are hydrogen atoms with a positive electrical charge. So they have more protons as electrons. And if something has more positive protons as negative electrons, that thing is positive. If it is not neutral, it is an ion, and these hydrogen ions, they are positive. They are hydrogen with more protons than electrons. So, and acids are giving hydrogen with more protons than electrons to something. Acid molecules, when mixed with or dissolved in water, split up to release their constituent ions. So, if now such an acid, which has hydrogen with more protons than electrons in it, is coming into contact with water, then the acid is releasing hydrogen. No, all acids release hydrogen as a positive ion. Yes, that means not just that it is a hydrogen ion, it is defined for that. So all acids which are doing that, donating, are giving off the hydrogen ions. Split up to release their constituent ions. And what does that mean? The hydrogen ion is splitting up to give off its hydrogen ion. The ions. Or the molecules. Molecules are bound together through different atoms, and now they are splitting to be able to give up their hydrogen to the water. Okay, acid-base balance. See also acid-base balance and alkali. Did we do alkali somewhere? We did alkali metals in chemistry somewhere. Let's go first to alkali. And we did already alkali acid balance system. Also in biochemistry. Alkali, also known as a base. Okay, alkali is the same as base, okay. An alkali is chemically defined as a donor of hydroxyl ions. And a base, or alkali, is giving hydroxyl ions, each of which comprises an atom of hydrogen linked to an atom of oxygen and has an overall negative electrical charge. Okay, acid are giving off positive hydrogen ions, and alkali are giving off a negative electrical charge and are bind together to an oxygen. Anti-acid drugs such as sodium bicarbonate, are alkalis. Some alkalis such as sodium hydroxide are corrosive. Okay, acid-base balance, a combination of mechanisms that ensure that the body's fluids are neither too acid nor too alkaline. The body has three mechanisms for maintaining normal acid-base balance: buffers, breathing, and the activities of the kidneys. Buffers are substances in the blood that neutralize acid or alkaline wastes. I think we did that. That was something in biochemistry. That was something which was able to take the positive and making something out of it, or taking the negative and making something out of it. The same thing could act to get too much positive down or too much negative up. Rapid breathing is another option to keep the acid-base balance of a human body. Rapid breathing results in the blood becoming less acidic. Slow breathing has the opposite effect. The kidneys regulate the amounts of acid or alkaline wastes in the urine. Disturbances of the body's acid-base balance result in either acidosis, that is excessive blood acidity, or alkalosis, excessive blood alkalinity. Now we have a definition of acids. It isn't too bad. I said something similar based on the other information, but it's good to have two sources next to each other. So acid. Acid is the definition of an acid is that it is giving off. I hope that is the proper way to formulate it. Giving off. It's just the way I want to formulate it, but I'm not sure if it's proper English. It is giving off hydrogen atoms, hydrogen ions, and these are hydrogen ions which are positive because they have more protons than electrons. And if they are mixing or dissolving in water, we are splitting. The molecules out of different atoms are splitting to be able to give off the hydrogen ion. And it is also always a hydrogen ion as a positive ion. That is the definition. So to say something more. That whole thing is important for the acid-base balance in human bodies. There can be also the alkaline. This is called with that one. Acid base in alkali is chemically defined as a donor of hydroxyl ions. The alkaline in the human body, they are hydrogen, not hydroxyl, hydrogen, what did I say there? Hydroxyl, at least here was oxygen. Okay, hydroxyl. Hydroxyl is hydrogen linked to oxygen. And they're giving off hydroxyl ions. And that is hydrogen with oxygen, linked together with oxygen, and that has an overall negative charge. That is not good. We're just going to make the water vision here. Acid, substance giving off hydrogen ions, which are hydrogen atoms which have a positive charge. That is the definition of ions. And if such an acid is, and it is also always a hydrogen, all acids are always giving also off these hydrogen ions as the positive ions. And if they're mixed with water, the molecules are splitting into their constituents, are splitting up to release the constituent, to release the ions. What are the ions of it? So the molecules out of different atoms, I guess, it's not said in a book, different atoms splitting up to be able to give off the ions, which is the atom. Just that it is differently composed. Okay. Acid. The definition of an acid is that it is giving off hydrogen ions to something. And hydrogen ion, these are just hydrogen atoms. Just that they are ions, so not neutral, but they are having more positive protons as negative electrons. And it is also in every acid the positive hydrogen ion, which is there given off. It is always an hydrogen atom. And if mixed with water, then the molecule would split up to be able to give off its constituent ions. That is according to the Illustrated Medical Dictionary written by Sue Davidson, Penny Preston, and Francis Williams on the page 8. But this is no substitute for medical knowledge and also no medical advice, and the positions and views expressed are the ones of the source and are necessarily aligned with our knowledge with the ones of entities spoken of. That was the biochemistry part. If you are here for biochemistry, you can go directly to the next part of biochemistry, where we will continue with biochemistry. If you stay here and participate in the Wristtraining, I hope that was right what we said. And have a good stand. Arms up, hands onto fists, and I'm going to check it a little. Again, down and up. If you participate in Wristtraining, and now hands like that, and in, and out. And we're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. Hands like that, in and out. The second rule is that we're going only as far as we can go with a little bit of effort. And the third rule is that we're not overdoing it, we just want to strengthen, not to exhaust. Hands up, and hands out, down, and up. You can take a break whenever you want. And fists, in, up, out, down, in, down, out. And one hand next to the body, down with the fist and press on the side. Also on the other side. And with the other hand, press, down, press. And now both hands up, press just, release, press, and again. Press with the fingertips of one hand on top of the fingernails of the other hand, open, close. And change. Both hands up, open, close. One arm out, try to flex the biceps, hand into extension with flat fingers and press against the back of the belt. In, try to flex the biceps, hand into extension, flat fingers, press against the back of the fingers. And in. Both arms up, strong fists into flexion, down and up. Turn it around, down, around, down, and up. And both hands up, flat hands, and bend the middle knuckles. Open again, and bend. Open, and bend. One hand, bend it and press onto the 4 fingers. Open. Other hand, bend and press on the 4 fingers. And open. And both hands, you can take a break. Both hands up and claw them. Try to flap them apart, the fingers. Open and claw. Open one more time. Both hands up. Down the flat fingers. Up with strong fists. Down the flat fingers. Up with strong fists. And both arms up. Strong fists into flexion. Out into extension. Flat fingers, in, strong fists, flexion, out. And hold up, both arms long, strong fists into flexion, out, extension, flat fingers, in, strong fists, flexion, out. Okay. And you can use a sock or something, have it with a long arm if you're outside. Let it fall down, try to catch it again. Wander slowly around, hand in flexion. Outside. And now go with moderate pressure of the middle part of the lower arm, and also on the other side. And then go carefully, so gentle, over the fingers, starting at the base of the fingers, and then whole tendon along. Don't pull at the digits, don't pull at the phalanges. And also with the other hand. You can press a bit at the finesse of the hand, but don't pull at the fingers. And that was the wrist training. I thank you very much, and until next time.